A red ball A is projected with a velocity of 10 meters per second at an angle of 30 degrees on a tabletop. A blue ball B is simultaneously also projected, but with a velocity of 12 meters per second at an angle of 60 degrees. And from the animation, it is quite clear that they cross each other without any collision. In this lesson, we will see how we can use the relative velocity concept to predict a collision. In the earlier lessons, when we had obtained the velocity of approach, if we viewed it from the frame of reference of A, it would always appear like B was moving towards it. But it was valid only for that instant in time. The picture would change at the next instant. So how can we predict a collision? Suppose we maintain the projection of ball A the way it was, and we change the velocity of ball B to 10 over the square root of 3. But we maintain the same angle of 60 degrees. In this case, we see that there is a collision. But why did the balls collide in this case and not in the previous one? Let's observe another case. Here again, we maintain the projection of ball A the way it was, and we change the release velocity of ball B to 12 meters per second and the release angle to 25 degrees. And in this case too, we find that the balls collide. Again, why did the balls collide in this case? Let's try and find the criteria to predict a collision. Let's say the ball A is released at 30 degrees and ball B is released at an angle of 60 degrees. We resolve both the vectors VA and VB along the line AB and perpendicular to the line AB. To predict if there would be a collision, we focus on only the component that is perpendicular to the line AB, that is VAY and VBY. To obtain the velocity of approach or separation, we focused on components along the line AB, but to predict a collision, we focus on components perpendicular to the line AB. If VAY is equal to VBY, or in other words, if the relative velocity of A with respect to B perpendicular to the line AB is 0, then A and B will collide. So VA times sine of 30 should be equal to VB times sine of 60 for a collision to take place. If the perpendicular components of the velocities of A and B are equal, it would mean that A and B cover the same perpendicular displacement in the same amount of time. And they will collide only if they are approaching and not separating. So the relative velocity between the components of the velocities of A and B along the line joining A and B should be the velocity of approach and not separation. If the ball VA is released with a speed of 10 meters per second, we obtain the velocity of ball B as 10 over the square root of 3 for a collision to take place by substituting these values into the previous formula, which was VA times sine of 30 equals VB times sine of 60. So anytime we have to predict a collision between two balls A and B, we can take the component of the velocities perpendicular to the line joining A and B, and if they happen to be equal, and if the balls are approaching each other, then there will be a collision. For a collision to take place, the relative velocity of the components of the velocities along the line perpendicular to AB should be 0. Also, the relative velocity of the components of the velocities along the line AB should be the velocity of approach.